let's do this orally first. Suppose that my two objects, one of them is a ping pong ball, the other one's a pickup truck. So the ping pong ball we throw at the pickup truck. You'd rather do it the other way? So, I'm not strong enough to do it the other way, even virtually. So I throw the ping pong ball that way at the pickup truck. The tailgate. It's up, it's not down. So what happens to the ping pong ball?
It bounces back.
It kind of bounces back, right? So to a rough approximation, we have ping pong ball, very small mass, coming in this way. Pickup truck, I cannot draw. Very big mass. That's the initial situation. The final situation is going to look probably a lot like this. Almost V naught. Still M. Pickup truck is just a flesh wound. So pretty small v. Let's ask, what's the momentum in the first picture? So I'm going to take to the right to be x. Can you see that from the back, Norwood? You all right? Initial would be how much? So this little m and that, and unit vector in the x direction, which I'm defining positive to the right. What's the final momentum? So this thing is moving at about v naught, but it's now going in the negative x direction. And the pickup truck, oops, big V, going that way. Positive x direction. So I could write this as a magnitude here, positive x direction. Okay, so the law of conservation of momentum, the principle that we deduced after all these arduous experiments that I dragged you through virtually, is that momentum is conserved in collisions that means P initial is P final. That's the fundamental principle that we're applying here. Besides that, these boards work really slowly. All right. So let's copy some more. So we have m v naught x. That's the initial. Must be equal to minus m v naught x plus m v x. Okay? Now, something really important. When I take the arrow off the vector, what does that mean?
Magnitude. It's a number. It's
a
scalar.
That means it's the magnitude of the vector. I can't do that because I can't add up and compare vectors and scalars. But when I take the vector sign off and write this, I mean the magnitude. If I meant only the x component, what would I write?
V subscript?
Yeah, v sub x. Okay, so we're going to have to be very careful because this momentum stuff, vectorial quantity. All right, I'm going to move this term to this side. So what's the answer? A. The momentum of the pickup truck is very approximately twice the momentum, the mighty momentum of the incident ping pong ball. Surprised? So it starts going this way, and then you have to turn it around and have it go back the other way. That's a big change. If the initial momentum going to the right is to be the final momentum, and you've got some momentum going back this way, well, the character who's going, the pickup truck that's going this way, has to carry more momentum than was initially present. Agreed? Your turn.